Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
A breakthrough discovery that could help geoscientists better predict an eruption and save lives.
The United States Geological Survey, USGS, has raised a red alert following unexpected and accelerated expansion of the Yellowstone Caldera's magma chamber, a development that has sent shockwaves through the scientific community and triggered heightened monitoring protocols across the region. The red alert, a designation typically reserved for imminent volcanic activity or extreme geologic instability, underscores the seriousness of what is now unfolding beneath one of the world's most closely watched supervolcanoes. Before we start, smash the like and subscribe buttons for more updates. Yellowstone has long been a focus of intense geological scrutiny due to its status as a supervolcano with an explosive history that spans millions of years. Its last major eruption, approximately 640,000 years ago, left a caldera nearly 45 miles wide and reshaped the landscape of what is now Yellowstone National Park. Though much of its activity in the modern era has been relatively subdued, marked by earthquakes, hydrothermal activity, and slow uplift of the ground, the latest data from satellite imaging, ground sensors, and deep seismic monitoring paints a different picture. Something significant is stirring deep within the Earth's crust. The magma chamber beneath Yellowstone, once believed to be slowly inflating over the course of decades, is now showing signs of rapid expansion. This discovery came after months of anomalous seismic activity and changes in ground deformation patterns that deviated sharply from historical trends. Instruments that track ground uplift began reporting faster than usual swelling across a broad region of the park, particularly in the Norris Geyser Basin and the caldera's western rim. What began as a gradual incline turned into a marked surge, prompting scientists to dig deeper into the cause. Geophysical imaging revealed that the magma chamber, an enormous reservoir of molten rock stretching several miles beneath the surface, was accumulating magma at an accelerated rate. This accumulation appears to be driven by an unusually active phase in the Earth's mantle, where hot, buoyant rock is pushing upward, supplying the chamber with new material faster than it can cool or disperse. This dynamic inflow of molten rock has led to an increase in pressure, causing the surrounding rock layers to bulge and crack. One of the most concerning indicators has been the sharp increase in harmonic tremors, low-frequency rhythmic earthquakes typically associated with the movement of magma. These tremors have become more frequent and intense in recent weeks, suggesting that magma is not only rising but moving within the system in complex and potentially volatile ways. Scientists have recorded swarms of earthquakes, sometimes numbering in the hundreds over a span of days, as the molten rock forces its way through the crust. Unlike typical earthquakes, which are caused by tectonic plates shifting against one another, these swarms are often shallow and localized, signaling that the activity is rooted in magmatic movement. This type of seismic behavior is consistent with patterns observed at other volcanoes in the run-up to eruptions, further validating USGS's decision to escalate the alert level. The declaration of a red alert is not made lightly. It requires clear evidence that conditions are rapidly evolving in a way that could threaten public safety. In the case of Yellowstone, the implications are far-reaching. A red alert does not guarantee an eruption is imminent, but it does mean that the system is behaving in a way that demands immediate and continuous observation. Every small shift in seismicity, ground deformation, or gas emission now takes on critical importance. Hydrothermal features across the park have also responded to the subsurface changes. Geysers have erupted more frequently, with some dormant features suddenly coming to life. Steam vents, known as fumaroles, have become more active, emitting higher volumes of sulfur dioxide and carbon dioxide, gases that often accompany magma nearing the surface. These shifts in surface activity offer yet another line of evidence that the magmatic system is becoming more energized. From a geological standpoint, Yellowstone operates as a pressure cooker sealed beneath a crust of varying thickness. The supervolcano is unique in that its magma chamber is relatively shallow, lying just a few kilometers beneath the surface in some areas. This proximity to the surface increases the potential for magma to breach the crust if pressure continues to build unabated. The composition of the magma, rich in silica, makes it particularly explosive due to its high viscosity, which traps gases until they are violently released. Understanding the implications of this rapid expansion requires delving into the nature of supervolcanoes themselves. Unlike typical stratovolcanoes, such as Mount St. Helens or Mount Fuji, supervolcanoes erupt not with towering lava fountains, but with colossal explosive events capable of blanketing continents in ash. A full-scale eruption from Yellowstone, while still considered unlikely in the short term, would be orders of magnitude more destructive than anything seen in modern history. It would affect global climates, disrupt agriculture, and cause massive population displacements. However, even without an eruption, the current activity poses significant risks. The expansion of the magma chamber could lead to the release of hydrothermal explosions, localized but powerful blasts of steam and gas that can be deadly to anyone nearby. Ground collapses or sinkholes may form as the Earth's structure is stressed, and the potential for toxic gas emissions is ever present. Furthermore, earthquake swarms can trigger landslides or damage infrastructure, particularly in areas like the Yellowstone Plateau where the terrain is already geologically unstable. The red alert also necessitates a re-evaluation of risk management strategies for the region. Emergency protocols are being reassessed, evacuation plans revised, and communication networks tested for rapid deployment. Park officials are coordinating with federal agencies to ensure that tourists and nearby residents can be notified at a moment's notice should conditions worsen. Scientific teams have increased the frequency of their fieldwork, using everything from drones to mobile seismic arrays to monitor the evolving situation. Technological advances in the past decade have allowed researchers to peer deeper into Yellowstone's inner workings than ever before. GPS stations mounted across the park now provide real-time updates on ground deformation, while satellite-based INSAR interferometric synthetic aperture radar systems offer a bird's-eye view of surface changes over time. These tools, combined with deep borehole sensors and gas monitoring stations, create a multi-layered picture of the system's health. Still, even with all these advancements, Yellowstone remains a largely unpredictable giant. Geological processes unfold over such vast timescales that even the best models can only offer probabilities rather than certainties. What makes this current phase so disconcerting is that it deviates from known patterns. Historically, Yellowstone has cycled through periods of calm and unrest, but never has the magma chamber expanded at this rate in the era of modern monitoring. The scientific community is now grappling with the task of interpreting the signals correctly. While a super eruption is the worst-case scenario, many other outcomes are possible. The chamber could stabilize after this surge, releasing pressure gradually through minor eruptions or increased hydrothermal activity. Alternatively, it could continue to inflate, leading to moderate eruptions that, while not apocalyptic, could still have serious regional consequences. The uncertainty makes preparedness all the more crucial. What's clear is that Yellowstone has entered a new phase of activity, one that warrants close attention and a deep respect for the immense forces at work beneath the surface. The red alert serves not only as a warning, but as a reminder of the dynamic planet we inhabit. Beneath the idyllic landscapes of Yellowstone, the geysers, hot springs, and sweeping valleys, lies a volatile geological engine capable of rewriting entire ecosystems in an instant. While scientists work tirelessly to decipher the signals and model potential outcomes, nature continues its own course, indifferent to human timelines. The magma chamber's rapid expansion is a stark indication that the supervolcano is far from dormant. In fact, it is very much alive, pulsing with energy and reshaping its internal architecture with every passing day. Whether this current episode will culminate in eruption or subside into another period of uneasy quiet remains unknown. But for now, the red alert stands as both a scientific milestone and a societal challenge. It compels us to ask uncomfortable questions about preparedness, resilience, and our understanding of deep Earth processes. In the coming weeks and months, the eyes of the world will be fixed on Yellowstone, awaiting any further developments that may determine the next chapter in this geological saga. While the issuance of the red alert marks a historic moment in the monitoring of Yellowstone, the ongoing developments have now shifted the focus toward deeper understanding of subsurface dynamics, especially in relation to the stratification of the magma body. Scientists have long theorized that the magma chamber beneath Yellowstone is not a uniform mass, but instead composed of multiple layers of varying temperature, viscosity, and gas content. With the current rate of expansion, these layers may be interacting in new and unpredictable ways, potentially altering the internal equilibrium of the entire system. This stratification has direct implications for pressure distribution. When hotter, less dense magma from the lower layers is forced upward into cooler, more viscous upper zones, it can trigger destabilizing reactions. Volatile gases trapped within the silicate-rich magma can exsolve more rapidly under such conditions, causing sudden increases in internal pressure. These interactions might not always manifest on the surface right away, but they can set the stage for future activity that emerges with little warning. This complex interplay of physical and chemical processes is what currently occupies the minds of volcanologists tasked with making sense of the situation. At the same time, there has been a surge in degassing events around certain geothermal features. These gas emissions are being closely analyzed for their isotopic compositions, as specific ratios of carbon, helium, and sulfur isotopes can indicate whether the source is from shallow hydrothermal systems or deeper magmatic sources. Recent readings show a marked rise in magmatic origin gases, confirming that material from the lower crust is indeed making its way upward with increased frequency. This kind of geochemical evidence adds another layer of confirmation to the rapid expansion scenario and points to a system that is experiencing new levels of agitation. Meanwhile, the deformation of the crust above the magma chamber is producing subtle but measurable effects on Yellowstone's surface hydrology. Changes in the pressure underground are starting to impact the flow and temperature of groundwater, leading to shifts in geyser activity and spring temperatures across the park. Some previously dormant springs have begun to bubble, while others have altered their flow paths entirely. These anomalies offer clues about subsurface pressure channels and help scientists refine their models of fluid circulation within the volcanic system. One of the more surprising developments has been the discovery of microfracturing patterns occurring far beyond the boundaries of the known magma chamber. These microfractures, detected using dense seismic arrays and laser-based strain meters, indicate that stress is being transmitted outward into areas previously thought geologically stable. This raises the possibility that the magmatic system's influence extends much farther than mapped boundaries had suggested, creating new concerns about how future seismic or volcanic events could impact areas well outside the current alert zones. The reaction among the scientific community has not been uniform. While most agree that the red alert is justified, there is an active debate over whether this represents the beginning of a long-term reawakening of the Yellowstone system or merely a transient spike in activity. Some experts argue that the current unrest could be part of a longer geological pulse that builds and releases energy over centuries, while others caution that rapid changes like these have historically preceded more significant events. In either case, the demand for higher resolution monitoring and long-term funding for volcanic research has never been greater. Beyond scientific circles, the broader implications for infrastructure, public health, and environmental stability are gradually being considered. In the event that the current activity escalates, even without a full eruption, large-scale disruptions are plausible. Air traffic over the region may face restrictions due to increased gas emissions or ash plumes from minor eruptions. Water supplies sourced from the Yellowstone watershed could be affected by chemical contamination or altered flow regimes due to subsurface heating and deformation. Local agriculture may also suffer, not just from potential ashfall, but from shifts in groundwater availability and soil chemistry. Communication protocols have become a central concern for emergency management authorities. The unpredictability of volcanic systems like Yellowstone means that warning times may be very short. Traditional alert systems are being supplemented by mobile push notifications, radio broadcasts, and satellite communications to ensure that any evacuation or hazard updates reach affected communities in minutes. This has prompted a wave of logistical planning exercises across Wyoming, Montana, and Idaho, with emergency response teams coordinating with geologists to rehearse scenarios that range from road closures to mass evacuations. Crucially, the psychological impact of the red alert should not be overlooked. Yellowstone looms large in the collective imagination as a symbol of natural power. The sudden shift from routine monitoring to high alert has reignited public fear and fascination in equal measure. Social media is flooded with speculation, often amplified by misinformation or exaggerated doomsday scenarios. Scientists are working to provide clear, factual updates to temper alarm while still conveying the gravity of the situation. Educational campaigns are also underway to help local residents understand volcanic hazards and differentiate between immediate threats and long-term risks. While much of the focus has understandably been on the magma chamber and its direct effects, some researchers are now looking at broader tectonic interactions. Yellowstone sits atop a hotspot that has migrated over millions of years, leaving a trail of volcanic remnants across the western United States. This mobility means that the deeper processes feeding the Yellowstone system may be tied to mantle plumes far below the continental crust. Studying the current expansion phase could provide new insights into how these deep mantle dynamics influence surface geology, not just in Yellowstone, but across similar hotspot systems around the globe. The increasing instability has also triggered interest in exploring lesser-known zones of weakness in the Earth's crust surrounding the caldera. Several fault lines previously thought to be inactive are now being re-examined for signs of reactivation. Early findings suggest that tectonic stress from the expanding magma chamber is placing new pressure on these faults, which could make them more susceptible to slippage in the event of further uplift or seismic activity. This raises a troubling possibility that volcanic and tectonic hazards may compound one another, turning an already dangerous situation into a multifaceted geological crisis. In academic circles, Yellowstone's red alert has sparked a flurry of interdisciplinary collaboration. Teams of geologists, chemists, hydrologists, and atmospheric scientists are pooling their expertise to construct predictive models that account for every variable, from the viscosity of magma to the distribution of underground aquifers. These models are continually refined with live data feeds, allowing simulations of different eruption scenarios or stress evolutions. Some models suggest that if the pressure continues to mount unchecked, a series of dome uplifts or phreatomagmatic explosions could occur before any large-scale eruption takes place, giving a clearer path for short-term hazard mitigation. At the same time, glaciologists are monitoring Yellowstone's ice and snow-covered regions for secondary effects. Should hydrothermal explosions or minor eruptions begin to melt surface ice rapidly, it could trigger flash floods or lahars, fast-moving flows of water, mud, and debris capable of causing significant destruction downstream. The interaction between fire and ice is a well-documented but often overlooked element of volcanic systems, and in Yellowstone's alpine terrain, it presents a real and growing risk as geothermal energy increases. Environmental scientists are also beginning to measure the cumulative ecological impact of the ongoing activity. Changes in soil temperature, gas release, and water chemistry are already affecting microbial ecosystems that thrive in Yellowstone's extreme conditions. Some microbial colonies are being displaced, while others are rapidly expanding in newly created thermal niches. This flux could have long-term effects on biodiversity in the park, and may even lead to the discovery of new extremophile species with unique biochemical properties. As pressure continues to build, there's a renewed sense of urgency among those who have dedicated their lives to understanding Yellowstone. The rapid expansion of the magma chamber has jolted the scientific community into recognizing that the supervolcano may not be as quiescent as previously thought. This doesn't mean that an eruption is imminent, but it does indicate a system in flux, one whose behavior is becoming increasingly difficult to predict with conventional models. What lies beneath Yellowstone is a world of molten uncertainty. As the magma chamber inflates and stress fractures multiply through the rock, one thing becomes increasingly clear. This is not a passive geological formation, but a volatile system in motion. The red alert is more than a warning. It's a call to observe, to learn, and to prepare for whatever comes next. Every rumble beneath the earth, every wisp of volcanic gas, every fraction of ground uplift brings with it the story of a restless giant whose next move remains a mystery. In this moment of intense geophysical awakening, Yellowstone stands as both a marvel and a menace, an awe-inspiring natural phenomenon that demands humility and vigilance in equal measure. The unfolding situation is not just a test of scientific knowledge, but of humanity's ability to coexist with forces far greater than itself. As Yellowstone's magma chamber expands faster than expected, the red alert serves not as a conclusion but as a prelude to a geological drama that is still writing itself beneath the surface of the American West. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Yellowstone's magma expansion? Natural cycle or serious threat ahead? We want to hear from you. Thank you for watching and see you next time.